All right, hello everybody. This is my trial run, making a video. We are going to attempt page 209, number 19. A softball diamond is a square whose sides are 60 feet long. Suppose that a player running from first to second base has a speed of 25 feet per second. So that's this distance right here. 25, her rate is 25 feet per second. At the instant when she is 10 feet from second base, what's the rate of the player's distance from home plate changing at that instant? So when she's right here, what's the rate of this distance changing at that instant? So we got a lot of variables to take care of here. 60, this part of this right triangle, this is not a variable, it's the constant. So we'll name this little variable x. We'll name this little variable h for hypotenuse. And the question is asking for what's the rate of change from home plate to her position at that instant. So we are looking for dh dt. Let's take inventory of all the variables that we have and all the variables that we're looking for. We have x. At that particular instant, x is going to be 50. Dx dt, we've got that one too. Do you guys know what it is? That's right, 25 feet per second. Feels like I'm talking to my 6th-hour class. Both of those variables were at that specific instant. We don't know h, but at that instant we can find h by sending this to the Pythagorean theorem. 60 squared, 50 squared equals h squared. Add those two together. When you add those guys together, we get 6,100. So h at that instant is 10 root 61 feet. And what are we looking for? We're looking for the variable dh dt. Now you got to remember that the x value is changing, just not at that instant. The h value is changing, just not at that instant. So at those instant ones, we have to keep those fixed for later in the problem. Let's write down an equation that has the variables x, h, dx dt, and dh dt. So first, to do that, we need a formula that has x and h's in it. That is the Pythagorean theorem. X squared plus the constant 60 squared is h squared. We're going to take the derivative of both sides of this equation, but with respect to time. It's very similar to implicit differentiation. So we take the derivative. So now we're going to use calculus. Up until now, we haven't had to do any calculus, just all algebra. So taking the derivative, take it down, multiply it around, it decreases by 1, but you just took the derivative of an h, tack on dh dt. The derivative of a constant is 0. And take it down, multiply it around, it decreases by 1. You just took the derivative of an h, tack on dh dt. So far, so good. Let's shove in the variables at that instant in time. So the runner is 50 feet away from first base, traveling away from first base at a constant rate of 25 feet per second. At that instant in time, the runner is 10 root 61 feet away from home plate, traveling away from home plate at a rate of dH/dt. So far, so good. Solving for dH/dt, divide both sides by this junk. The 2's cancel. 10 goes into 50 5 times. 125 over the square root of 61 feet per second. That's the rate at which she is running the distance between her and home plate. If you guys have any questions about this or any of the other problems, feel free to email me. I hope this video is helpful. Sorry it took so long. Stay healthy, everyone, and try to do some calculus every day. Keep it fresh.